Good evening, ladies and gentlemen, and welcome to RUMC's Keynote speaker session. We first started the series to commemorate our Silver Jubilee anniversary last year, and after a successful series of addressing pressing health issues last year, we're back with a new RUMC's Go Beyond Keynote speaker series featuring healthcare experts as they share their perspectives on current health issues in Malaysia. First of all, thank you so much for joining us this evening. I'm Kasturi, the PR and Comms Specialist at RUMC, and I'm happy to be your moderator for today. Now, before we begin, let me take you through the housekeeping guide so you would know how to navigate around the platform. You should be able to see your attendee interface on the computer desktop on your right-hand corner. And by default, you're listening to the session using your computer speaker system, and you will be put on listen-only mode. You'll have the opportunity to submit text questions to our speaker by typing them out on the questions tab in the control panel. And please feel free to send in your questions at any time during the event. So today's highlight is childhood vaccination. The Vaccination Malaysia schedule was based on the development program called Immunization program designed by the World Health Organization WHO. And according to the program, each country is recommended to offer immunization for 6 main types of childhood infections. And in Malaysia, the government has increased immunization coverage to 12 major childhood infections and also cancer. So a report from WHO stated that 2 to 3 million deaths from infections such as measles, diphtheria, tetanus, and influenza have been successfully prevented. So why should children be vaccinated according to the recommended schedule? And is it necessary and important for children to get the COVID-19 vaccine? Today we'll get the answers to the need for vaccination among children and the ongoing recommendation on COVID-19 vaccines for children. Now, allow me to introduce our distinguished speaker for today, Dato Dr Hussain Imam. Hailing from Penang, Dato Hussain graduated with MBBS from University of Malaya in 1980. He went on obtaining several more qualifications, which includes membership of the Royal College of Physicians in the UK, Diploma in Child Health from London, the Fellowship of Royal College of Physicians in Edinburgh, Fellowship of the Royal College of Paediatrics and Child Health from the UK, and he's also the Fellow of the Academy of Medicine Malaysia. Dato Hussain is currently a practicing pediatric neurologist and the head of pediatrics at RUMC. So without further ado, I'd like to welcome Dato Dr Hussain to begin. Dato, welcome. Over to you.
Thank you, Kasturi. Good evening, assalamu alaikum, ladies and gentlemen. It gives me great pleasure to share some discussion points about vaccination for children and why it is safe and important. Vaccination is considered the most important medical development of the 20th century after the provision of clean drinking water. It's also considered the most cost-effective intervention by WHO. It has resulted in the eradication of smallpox on a worldwide basis and eradication of polio in most countries, including Malaysia. It's also eliminated most cases of bacterial meningitis in countries with Cape and pneumococcal vaccines in the extended program of immunization of EPI. This is the current national immunization schedule for Malaysia. As mentioned, Malaysia offers more than the basic 6 antigens for immunization. We have BCG and hepatitis at birth. At 2, 3, and 5 months, we have a combination of vaccines to prevent diphtheria, tetanus, pertussis, polio, hepatitis B, and measles influenza type B, with a booster at 18 months. We have measles only for sub at 6 months. The measles, mumps, and rubella vaccination is given at 9 and 12 months. The pneumococcal vaccine, which is the latest vaccine introduced into EPI in Malaysia, is given at 4, 6, and 15 months. In Sarawak, we have vaccination against Japanese encephalitis at 9 and 21 months. We are at school, we have a sort of DT booster at standard 1, and then we have a boost. We have the hemopapillovirus vaccine for girls at 13 years of age and standard 6 to prevent against cervical cancer. And at 15 years at Form 3, we give the tetanus vaccine booster as well. Now, what has been the impact of all these vaccinations in Malaysia? This is for poliomyelitis. We had the last major outbreak of wild poliovirus in 1977. For that, we introduced nationwide immunization, and we have actually largely been polio-free. We had 3 cases imported from the recently liberated Central Asian states in 1992, and we had importations of vaccine-derived pediatric polio in Sabah from Philippines in 2019-2020, but that's long since become under control, and we are now again declared by WHO as polio-free. Malaysia actually was one of the pioneers for introducing a vaccine against meningitis. This is influenza type B vaccination. We introduced the vaccine in 2002, and even as of 2006, if you notice that we were the only country in East Asia which offered the vaccine free of charge in its EPI. Many other countries were offering it only in private practice. Measles is another success story. This is how we manage measles. Initially, we introduced only a single dose of measles vaccine at 9 months, and that really again succeeded in controlling intermittent outbreaks every few years. So then we introduced a 2-dose schedule in 2002, and we had a catch-up dose for all those under 7 years of age. And then we had another outbreak here, so then we had a targeted immunization of certain pockets of the population. And then more recently, we've introduced a change in the schedule. So now the measles is given at 9 months and 12 months instead of at 1 year and 6 and 7 years. So if you notice that we now still have the occasional death from measles, and this generally is among those who are not being vaccinated. Unfortunately, this is still a problem. There are some individuals who refuse vaccination, and then they succumb to an entirely preventable disease. In diphtheria as well, we introduced the vaccine, and then we've had a very good sort of success story with the vaccination. But unfortunately, there are still some pockets of individuals who refuse the vaccination for various reasons, and we had 6 deaths in 2019, and we're still waiting the more recent data. So this is unfortunate. Again, pertussis, right? Here we have again a very good success record, but we still have pertussis cases. And this usually tends to be breakthrough sort of infections in the older age group, because the vaccine tends to sort of wear off as you go to adolescence, and because there's no maternal antibodies, newborn babies are vulnerable to pertussis until they get their first dose of the vaccine in 2 months. Recently, the ministry has resolved as this decided to give all mothers pertussis vaccine pregnancy to try and prevent this happening. All right, so we are doing very well in vaccination throughout the world. Then there was the emergence of the anti-vaccine lobby, fear of side effects of vaccines, febrile seizures, local pain, the rare Guillain-Barré syndrome. And then there was an issue of thimerosal and vaccine as adjuvants, and then this was blamed for mercury poison leading to autism, despite the fact they used minuscule sort of amounts of thimerosal in the vaccines. MMR and measles vaccine was then blamed for an increase in incidence of autism, and this resulted in declined immunization rates globally. I mean, for example, in the UK, vaccine rates came down from 92% to 84% for the second dose of the measles vaccine in 2002, following the scare of the MMR vaccine and autism. After that, there were numerous studies done in many European countries in the US, and this has clearly proven that there's no association between MMR vaccine and autism. In particular, there were some countries with very good data that were able to produce data showing the incidence of autism before and after the introduction of MMR vaccination into national programs, and there was no increase of autistic diagnosis rates following the introduction of MMR. But while all this was happening, thousands of children in UK and Europe were coming down with measles and mumps because immunization rates had fallen. Now, lots of hard work on the public authorities and public awareness. The rates have come up again, but even as of 2018, there were 991 cases of confirmed measles in the UK, and I think 2020 there were 3 deaths in Ireland from measles, entirely preventable as well. Now, then of course there is the current controversy, the vaccination for COVID-19, and in Malaysia we still have an issue that the uptake of the vaccine in the pediatric population, in certain segments of the population, is far from optimum. So let's look at this. There are various groups of people who are opposed to vaccination, and this is not new. This is not new, right? When there was a law passed in the United Kingdom to make smallpox vaccination compulsory, this was a response of a physician in London. He says, many of us would prefer an attack of smallpox to vaccination. All of us would prefer the risk of smallpox to the certainty of vaccination. Smallpox is a natural disease running a known course. Vaccination is a loathsome disease of uncertain origin, artificially transmitted through various species, capable of setting up a variety of repulsive, dangerous, and even fatal infections. So this was an objection by a member of the medical community to the introduction of compulsory smallpox vaccination. Fortunately, no one listened to him, and we went on to have obligatory compulsory smallpox vaccination across the globe, resulting in the eradication of smallpox. So now actually smallpox actually doesn't exist except in some laboratories for research purposes. The vaccine has been eliminated from us. So this is fortunate, because if we had listened to all these anti-vaccine lobbies, we never gone any far forward with smallpox eradication. Yeah. Then, of course, there's the other group of people who are concerned about the safety of the new technology used for the COVID-19 vaccines. If you that older technology has established safety record, and they prefer the older techniques of preparing the vaccine as opposed to the new generation vaccines. So let's look at the various kinds of vaccines we have in our country. We actually have got 3 vaccines in the country. There is the Fizer BioNTech vaccine, which is mRNA vaccine. There's AstraZeneca vaccine, which is a viral vector vaccine. And then is the Sinovac vaccine, which uses attenuated virus. So if you look at the classical vaccine, they use inactivated virus. So they take a virus, and the virus is prepared in cell culture, and then it is inactivated, that is injected. All right. The process of manufacture, the technology is quite simple, and theoretically speaking, you give multivalent antigens and should be able to protect against future viral variants, right? Theoretically speaking. Because the fact that you're handling live viruses, it's a fairly complex manufacturing process, and it's difficult to rapidly scale up production because there are safety issues about handling live viruses. Overall, it is less reactogenic than live viruses, and it produces a weaker immune response. The examples available in Malaysia are Sinovac and Sinopharm. Then there are the new generation vaccines. There's the viral vector-based vaccine, which is a high degree of safety due to years of proven experience in the gene therapy field. This technique of introducing a protein into a human cell using a viral vector has been used actually to treat genetic disorders, and successfully, right? So although there's a theoretical risk of infection and chromosome integration, oncogenesis, because you have more than 10 years, 15 years experience with this, with genetic disorders, we are quite confident. It induces a strong cellular and humoral response, and because they imitate the natural infection, and it can be stored at 4 degrees centigrade, standard sort of laboratory freezers. So the example of this vaccine is AstraZeneca vaccine, which is available locally. Then there's the messenger RNA vaccine, right? RNA stands for ribonucleic acid. And mRNA is actually the mechanism by which cells produce protein. The DNA from the nucleus will produce mRNA. mRNA goes on to the cell cytoplasm and initiates protein synthesis. This is actually a safe process because there's no live virus handling during the development. It's entirely sort of lab prepared mRNA. Rapid developments and production, flexibility to introduce multivalent vaccines in events of virus variants arising. There is no risk of jet integration because it doesn't go and work on the DNA. It works only on the cytoplasm and the mRNA. Induces a very strong immune response. The disadvantage of RNA is rather fragile and requires ultra-cool chain requirements. So, for example, the Pfizer vaccine requires -70 degrees for storage. This is an issue in terms of logistics and in terms of delivering the vaccine to the peripheral parts of any country. So the other vaccine which is available is Moderna, which is still not available in Malaysia, but it's also an mRNA vaccine. So how actually do vaccines work, right? So vaccines imitate natural infection and elicit an immune response in the body. So this results in the formation of memory cells capable of producing specific antibodies and killer cells that will prevent the relevant virus or bacteria from establishing an infection in the future. So the success of a vaccine in eliciting immune response depends on to what extent it can stimulate the relevant pathway in the immune system of our bodies. Live vaccines are more efficient in stimulating the immune system than vaccines contain inactivated cells or the protein of a virus or a bacteria. Coming specifically to the SARS-CoV-2 or the COVID-19 infection, viruses cause disease by entering our cells and taking over the protein-producing mechanism of the cell, directing it to make new viruses, right? So this is achieved by the genetic material of the virus taking over the RNA and the DNA of our cells, and then the DNA RNA then reprogrammed to produce proteins which will result in the production of new viruses. Now, vaccines largely work by preventing the virus from entering the cell and preventing this cascade of events that results in the production of new viruses at the expense of the cell, and the cell eventually dying in the process. Now, in the case of the SARS-CoV-2 virus, it is the viral spike protein that binds to receptors of our cells, allowing viral material to penetrate our cells. So therefore, the vaccines that we have work by stimulating antibody production against the spike proteins. Now, let me sort of illustrate this with some cartoons. So this is a cartoon version of the COVID-19 virus, right? So this are the spike proteins. This is blue. These are the spike proteins, right? This is the nuclear capsid in the nucleus. This is the membrane, and this is the envelope. And this is the RNA of the viral genome. The vaccines which make use of these viral proteins are not currently available in Malaysia. I'm not going to discuss them any further. When we discuss mechanism relevance of the vaccines in our country. So this is an enlarged version of the viral spike protein, and this is what it actually looks like, right, in the lab situation. So this is the part of the virus that binds to our cells. So this is known as the receptor binding domain, right, the RBD. So this is where it binds our cells, and that allows the viral particles to enter. So once the viral particles enter our cells, then they take over the function of the cells. And here we see the cell, this infected cell, producing and releasing numerous new viruses into the environment, and this will then go on to infect the neighboring cells. So this is the environment of the body, right? So it's inside the body. So this is cell releasing the new informed viruses into the circulation, and this will then go to affect other cells in the body. And you can imagine this, from one infected cell, we've got numerous hundreds of new viruses will affect hundreds of other cells, right? So this is how the infection becomes established. So how does the virus work? Well, you take the AstraZeneca virus, all right? So the virus, the DNA is inside the adenovirus, which is then injected into the body, and then the virus will link up with the cells and then will release the DNA into the cell, and this will then make the cell produce the spike protein on the surface of the cell, and this will then elicit the immune response, right? So then body produces antibodies against spike protein, and in future, if the virus enters the body, then the antibody response will very quickly check the spread of the virus by binding to the spike proteins. This is the Fizer vaccine, the BioNTech Fizer vaccine, where the mRNA coding for the spike protein is covered in a lipid nanoparticle, something like a soap bubble, right? This is injected into the body. Once it's absorbed onto the cell, then mRNA is released into the cell, and then it results in the production of a spike protein, and similarly will result in an immune response. This is the Sinovac vaccine. This is making use of it. So you have the whole virus here, right? And the whole virus is inactivated by various processes in the laboratory. And then this inactivated virus is then injected into the body, and then it initiates a response. Because it is an inactivated virus, the immune response is, generally speaking, not as good, right? So let's go into some more details about what actually happens in our body. So if you take the Pfizer vaccine, so this is the mRNA, right, the lipid nanoparticles. You inject it into circulation, it goes into the cells, and then it produces the spike protein, right? The spike protein is then taken up by what is known as antigen-presenting cells. So these are cells in the immune system, and once you taken up this, then they will result in the production of, immune cells called B cells, which are responsible for the production of specific antibodies. And these antibodies are directed against the spike protein. So in the future, you get this coronavirus entering the body, then immediate antibodies will bind to the spike proteins. So the spike proteins cannot make connection with our cells, cannot initiate an infection. On the end, they also produce another group of cells called the T helper cells. So in the case of these T helper cells, when there is a cell that is already infected by the virus, then these activated killer cells will then kill off this cell before there's opportunity to make new viruses and cause infections within the body. So this is how it works with mRNA. In the case of the Sinovac vaccine, Sinovac vaccine, this is inactivated virus which is injected to the body, and then this will then be presented without any further processing into the antigen presenting cell, right? And this is the AstraZeneca vaccine, where you have this viral vector-based vaccine, and then this will then result in the cells coming in here and the DNA from the virus, from the vaccine going to the cells, producing specific proteins which will help identify the virus and then antibody production again. Right? These are the mechanisms are not relevant because this virus, this vaccine is not available in our country at present. So, what is the real world effectiveness of the COVID-19 vaccines? If you looked at the experience we've had over the last few years, we were given, these vaccines to millions of individuals around the world. What is the actual real-life vaccine efficacy, right? This is a paper published recently by a group of Chinese researchers in the Chinese University, International Journal of Infectious Diseases. So they looked at 105 papers, but because all the papers of good sort of research quality, they then selected 51 papers from 14 countries, right? Looking at the various viruses. The vast majority of the papers actually on the Fizer vaccine. So this is the Rna Vaccine. This is the coronavirus. Coronavac is actually the same thing as Sinovac. It is called Coronavac in South America, right? There are 3 papers here on coronavirus from Chile and from Brazil, because this is the predominant vaccine used in South America. Most of the other countries are using Pfizer. There's only 1 paper from India on AstraZeneca vaccine, right? So if you compare the sort of vaccine efficacy, this is the range of efficacy, and this is the confidence interval. Just speaking, the confidence interval crosses the line of 0, means that the vaccine actually is not working very well. So when you look at this study in Brazil, actually the confidence interval actually crosses the 0 line, but in that particular study, the vaccine probably wasn't really effective. So this is a comparison in real life of the efficacy of the vaccines available in our country, right? Overall, looking at specific parameters, right, in this study, they looked at 4 parameters. They looked at severe acute respiratory syndrome, coronavirus, SARS-2. They looked at hospitalization rates, look at admission to intensive care, and look into death from the SARS infection. So in terms of preventing an infection with the SARS-2 coronavirus, there was 89% success rate. Combining all the vaccines, combining all the studies together in this population in 14 countries, this was the overall vaccine effectiveness, 89% in preventing infection. There was a 97.2% success rate in preventing hospitalization with a fairly narrow confidence interval. This is good. I mean, narrow confidence intervals imply that the quality of the data is good. Admission to intensive care, again, 97.4%. But again, a very narrow confidence interval implying it's good data as well. And death, right? We find that 99% success in preventing death. Even if they're admitted to hospital, even they have intensive care, the vast majority of them do not succumb, right? So this is again good interval. Looking at the individual vaccines, and for those fully vaccinated, observed effectiveness of the vaccine study, the Pfizer BioNTech vaccine is 91%. The Moderna vaccine is 98%. Both of these mRNA vaccines. There was only one paper from India on AstraZeneca, so they didn't want to comment because they said that that was not enough. And that on the Coronavac Sinovac vaccine, it was 65.7% efficacy. Now, let's look beyond individual. Okay, so you vaccine the individual gets protection, right? So if many individuals get protection, then this has an effect on the community transmission of the disease, right? So if more individuals are sort of protected from getting the vaccine, or getting the infection themselves, they also will indirectly prevent other individuals from becoming infected. This is referred to as herd immunity. Let me explain this in some sort of cartoons. Right? Take this herd of cattle, right? This is a herd of cattle in which this particular cow is infected with a disease, whatever it may be, right? Now, if none of the cows are vaccinated, then from one cow it can then spread to almost all the cows in the herd, and that's it. The whole herd gets infected, isn't it? Right? So that's when you get into the problem. On the other hand, if some of the cows are vaccinated, all right, then this disease from this cow cannot spread to the cows that are vaccinated. And then other cows beyond that are not vaccinated are still protected from infection because of these vaccinated cows. Whereas these cows are not vaccinated, and then they will get the infection. And if they come into contact with any other cow, they will cause infection there as well. So this is called herd immunity. These cows that are infected actually protect the other cows that are, for some various reasons, not vaccinated. So these cows that are vaccinated will protect the other cows that are not vaccinated from becoming infected with the disease, whatever it may be. Now, why is this important? Right? Not every individual in a community can be vaccinated. Some of them are immunosuppressed. Some of them have allergic and anaphylactic disorders. So these individuals who cannot be vaccinated will depend on the herd immunity of all those vaccinated around them in order for them to be protected, right? So this is important. Because if you look at any population, you cannot achieve 100% coverage. But if you achieve 95% coverage, you can safely say that the other 5% will be protected by immunity. Now, how safe is the COVID vaccine for children? Until the end of December 2021, 8.7 million children between 5 to 11 years of age received the Pfizer BioNTech vaccine in the United States, right? From these 8.7 million, there were 4,249 cases of adverse effects following immunization, so-called AEFI, this reported to the CDC. Of these 4,249 reports of adverse events, 98% were mild. There were only 100 cases of severe adverse events, which include things like fever and vomiting. But of these 100 cases, 11 had myocarditis. Of the myocarditis, at the time of reporting, at the end of December 2021, 7 of the 11 had recovered completely. You may take for the next report to come on, see what happened with the other 4. How about our local data in Malaysia? In Malaysia, as of March the 18th, we have immunized 1,239,194 children with between age of 5 and 11 years with the COVID vaccinations. The majority of patients received the pediatric version. Pfizer BioNTech is sort of unique in that they've actually got a pediatric version, right? The children get a 10 microgram dose of the vaccine, whereas adults get a 30 microgram dose of the vaccine. The other vaccines, like the coronavirus vaccine, they don't actually have a pediatric preparation, but since it's the kill vaccine, it doesn't make any difference. Now, so far from this 1.2 million plus, there have been 207 adverse events reported, right? involving these children between 5 to 11 years of age. Of these 207 adverse events, 97% were not serious. Of those that were serious, right, there were 7 who were serious, and of the 7, 6 of them required admission to the ward for treatment and for the monitoring, but all of them have since been discharged. One child of the 7 was brought in dead, and this caused a lot of confusion. But this is a child who had a congenital abdominal malformation and undergone previous surgery and actually intestinal obstruction as a consequence of previous surgery, and the death was unrelated to the vaccine. It was a complication of previous surgery for a congenital malformation of the illness. So look at the rates of adverse events in Malaysia for children between 5 to 11 years. Our rates is 0.2 reports per 1,000 doses. This is comparable to Canada, 0.15 per 1,000 doses, and Australia, 0.6 per 1,000 doses. And the adverse events reported include headache, fatigue, pain, redness, and swelling at the injection site. So overall, this is a safe vaccine. Now, let's look on the other hand. How is the spectrum of COVID-19 cases in Malaysia? Between July and December 2021, there were 278,383 cases of COVID-19 in children below 12 years of age. Of these, 63 children died, giving a rate of death of 1 per 4,418 children infected actually succumbed to the illness. 100 children, i.e. one in 2,783, developed what is called the multi-system inflammatory syndrome in childhood. This is a fairly unique immune syndrome in the pediatric population. Based on overseas data, up to 10% of infected children may actually go on to develop the long COVID syndrome. Now, what is this multi-system inflammatory syndrome in children? This is a syndrome where, in 100% of them, they get cardiac involvements, right? Some of them go into shock, right? Some of them actually require very intensive chemical use of ECMO, which is a very sophisticated intensive care. They get coronary dilatation, pericarditis. So 100% of them get involvement of the heart. Then you get almost 90% get involvement of the eyes, get cracked lips. 1/3 get involvement of the brain, right? And then involvement of the lymphatic system. They get a rash, and 83% of them will get nausea and vomiting. Some of them will get digestive involvement to the extent that some patients actually end up getting laparoscopy because of worrying that there was some obstruction going on. So this is a fairly serious thing. All right, and most of them, get a sense of weakness and fatigue or asthenia in 100% of them. So this is a complication that's almost unique to the pediatric population, right? So if you were to compare, therefore, the severity of the illness from COVID-19 in our local pediatric population, and you want to compare the very rare side effects and get to 97% minor side effects of the 1.2 million children who received the vaccine. This is clearly a vaccine that has got a good track record of safety. There's global data from overseas showing that the vaccine is very effective in preventing infection, hospital admission, ICU admission, and death. Right? So therefore, we strongly urge all Malaysian children vaccinated against this virus. And as we know, a minority of children will not qualify for the vaccine for various reasons. And it's hoped that the good coverage among those children who have received the vaccine, who are qualified to receive the vaccine, will protect this children to herd immunity. Right. Thank you very much.
Thank you so much, Dato Hussain, for the insightful sharing on vaccination for children and its importance in the long run, and also for highlighting the need and safety of COVID-19 vaccine among children. So without further ado, let's move on to the Q&A session. And a gentle reminder to the audience, you can still send in your questions and we will try our best to address them all now. Okay, let's look at the questions. Okay. Okay, a few questions from Mr. Kenneth. First one, dear Dato, thank you for sharing. May I ask, is it safe if the second vaccination for COVID-19 for children is less than 2 months? And in your opinion, are the possible outcomes of the effect of the vaccine if the vaccination is more than 2 months apart?
Okay. Generally speaking, if you have an infection or you have a first dose of the vaccine, then the body doesn't respond very well to the second dose of the vaccine for 3 to 4 weeks, right? So generally speaking, we would like an interval of 3 to 4 weeks between two vaccine doses. If it's a bit longer, it doesn't matter. But if it's shorter than that, the body may fail to mount a good response to the second dose because it's still sort of dealing with the first dose.
Right, Dato. And the other question from Mr. Kenneth is that, in your opinion, do you believe that children requires 2 doses of vaccination for COVID, or is 1 dose enough for them to develop immunity against COVID-19 in later years?
Right. All the papers which I showed actually will actually give 2 doses of the vaccine. When they looked at countries where there was data for only 1 dose, the protection rate was not as good. Yeah. So we now know very clearly from data overseas that 1 dose of the vaccine protection rate is actually much less than 2 doses of the vaccine. You don't get figures of going to 90+% with a single dose of the vaccine, any of the vaccines.
Okay, Dato. Thank you. And another common question that I think most of the public would have is that they think that their children is healthy and strong. And why is there a need for them to be immunized despite their children being healthy and strong, Dato?
Okay, so this is also a common misconception that because the child is otherwise well, that the child will be able to cope with an infection and get natural immunity. And this is the reason why, for example, we still get deaths from diphtheria, we still get deaths from measles, because of this concept that, you know, my child is strong, I don't need to get the vaccine. When a child gets the diphtheria or the measles, the child's body responds in unpredictable fashion, and then the child succumbs, right? So, you know, so this notion of natural immunity, this notion that my child is well, is not a sick, malnourished child, I don't need the vaccine. This is the reason why there have been dropouts from the vaccination rates in Europe. They feel that this is vaccination is for third world countries and very rich world countries. We don't need the vaccine. And then we see thousands of cases of measles in Europe and in UK, when before there were no cases at all. So there's enough data, real world data from the measles, mumps experience, and from the diphtheria experience to tell you confidently that this is not true rationale.
Okay, Dato. And the next question is, why is there a need of multiple doses for certain vaccines? I believe this question refers to the childhood immunization part. For example, the MMR has 2 doses, the hepatitis B has 3 doses and a booster. So why is there a need for multiple doses?
Okay, let me take the measles vaccine, right? No vaccine has 100% efficacy, right? So if you take the measles vaccine, if you give 1 dose of the vaccine, then you might get something like 90% of coverage. There's 10% not covered. When you give a second dose of the vaccine, the protection goes up to more than 95%. And we need the 95% protection to achieve herd immunity for those others, because measles is a live vaccine. Therefore, we cannot give it immunocompromised individuals, those who are not been treated for various conditions with steroids or with child cancer or something. So, in order to achieve 95% coverage or protective coverage, you need to give enough of the vaccine until 95% of them are protected. Because if you give hepatitis vaccine, if you give 1 dose, you make 80-something% protection. If you keep giving more and more, then you'll be able to achieve a 95% protection efficacy in the population, right? Then you take the kill vaccine, then you take the bacterial vaccine, for example, DTP, the vaccine against influenza type B, against pneumococcal vaccine. It is found that the memory cells, if you give 1 or 2 doses, or even 3 doses per year, by 18 months, memory cells actually seem to have come down, and the response is not so good. But I find that if they give a booster at 18 months, that this sort of boosts the memory cells, right? And then later on, if they're infected, they will be able to protect it against the infection. Then again, you know, the efficacy goes down. So you need to boost it again, say, for tetanus. Because tetanus, you're likely to expose throughout life because of injury. So we give 1 at 7 years, we give 1 at Form 3, because tetanus is due to physical injury, you know, cuts and boots and so on and so forth. And, you know, tetanus, we need to give it every 10 years in order to maintain, to protect the efficacy of the vaccine. Because over time, the memory cells will decline, right? And then the response of the body depends on the presence of memory cells. Memory cells are not stimulated for a long time, then they don't survive. Then they're not transmitted the memory to other cells in the immune system, and then you're exposed to the infection, and there are no memory cells to take on. So you need these boosters all the time.
Thanks, Dato. And moving on with the next questions, there seems to be too many childhood vaccines, too many types of childhood vaccines. Won't my child's immune system be overwhelmed? This is also because if you see babies, they are given vaccination almost every month until they are 6 months old. So isn't it too overwhelming? And what is your opinion about it?
Okay, if you look at what happens to babies before vaccination, if you look at even Malaysian data, I forgot to start unfortunately, about infant mortality. Before we had the vaccines, Malaysia had a very high infant mortality, about 70 to 100 something per thousand population. Now infant mortality was 7 to 9 per population, right? And this largely is because of few things: malnutrition, and number two, because of control infection for immunization. Those days, children died by the thousands from measles, from smallpox, from pertussis, from diphtheria, and die from diphtheria is a terrible death. Die from pertussis is also not very pleasant. I mean, not that pleasant after all. And in measles, those get measles, 1 in 10,000 get this is called SSP, which is a brain disorder, which is no treatment. They die very slow death as well. So all of these conditions have been prevented by vaccination, right? Now, one of the problems is that we're in a situation where many people have not seen a case of diphtheria. They have not seen a case of pertussis. So they say, you need all these vaccines. This is what happened in Europe, what happened in UK as well. People are thinking, all these diseases are a thing of the past, and now we no longer have all these diseases in the community. So we cannot give vaccine to our children and spare them the pain of the injection and the side effect vaccine. And then what happened? We had a surge of pertussis in Germany and in France because they didn't want the pertussis vaccine. We had a surge of measles and mumps. And now we have deaths from measles in the UK island. And this is why, because the infection is there. You don't give the vaccine, the infection will make a re-emergence. It doesn't go away. We have not, if you want to go away, if you eradicate like smallpox, right? Everybody gets a vaccine throughout the world, then you can eradicate. We're trying to do that with polio, but we're not succeeding because of the anti-vaccine lobby in some countries. So we still got some pockets of polio. So this, you must understand that when a child is born, the child is essentially immunized. There's some protective antibodies from the mother, which will last about 3 months. Because the antibody IgG from the mother will do specific immunity about 3 months. Then the child will be exposed to numerous infections in the community. And then maybe they get a bit better. Then they go to childcare and they get a surge of infection because of exposure to more other children in childcare, and then they get auto-infection again. So these infections are occurring at a time when the child actually is very young, and your child gets infected. The risk of death is serious. So that's why we give all these vaccines in a hurry in the first year of life, so that they don't get these infections, which can cause death, and which in the past caused death by the thousands. In fact, globally caused death by the millions. One time there were 5 million deaths a year for measles, right? That's come down to about 1 million, 2 million. But this is because of vaccination coverage. So to die from measles, it's very sad because this is a highly preventable disorder. So there's a hurry to give these vaccines in children, because if they were to get the natural infection, they may succumb, they may die. And they did die in the past.
Thanks, Dato. That was really a very clear explanation. And moving on, the next question from Ms. Doreen. How effective is Pfizer and Sinovac in preventing infections? Some studies show only about 30% effectiveness.
Sorry, Pfizer and?
Pfizer and Sinovac, Dato, in preventing infections.
Those are two different vaccines. Pfizer vaccine is a live vaccine, and as I showed the data, generally speaking, the Pfizer vaccine is more protective than Sinovac. Is actually a kill vaccine, so it doesn't stimulate the immune system as well as the Pfizer vaccine. If you look at the data which I showed, isn't it? Most of the other vaccines, I know, they're 90% sort of protection effectiveness, whereas Sinovac was 65%, right? And some of the studies in Brazil, it's gone as far as low as 37%. So this is the problem. But it's not unexpected because of the nature of the vaccine. It's also inactivated vaccine. So in a sense, stimulate the immune system as well as the mRNA vaccines and the viral vaccines.
Okay, that Ms. Doreen also has another question. How soon after a natural COVID infection should a child be immunized? Yeah.
It's the same thing. It's the same as the first dose, 3 to 4 weeks after natural infection, because the body won't be able to respond to vaccine before that. So then it's a good idea to wait about a month, and then you take the vaccine.
Okay, that's and then this is back to the child immunization. Are there any reasons why any babies or children will not be immunized?
If a child is immunocompromised, and for a child, for example, there are some children who inherit a deficiency in the immune system, which means they will not be able to mount a response. And some of our vaccines which you give, the measles, mumps, rubella vaccine given at 9 and 12 months, actually live vaccines, right? This is also a live vaccine. Then they will not be able to cope with the live vaccine. So one, they won't be able to respond to the vaccine because the immune system is deficient because of congenital inherited disorders of the system. Number two, they may actually get problems with live vaccines. Then, of course, there are those children who are treated, for example, children who get kidney disorders, given high dose steroids, children with childhood cancers, given high dose of medication will suppress the immune system, and they also won't be able to mount a response to a vaccine. Therefore, they need to protect the herd immunity.
Okay, Dato, and this is going to the COVID-19 vaccination. My nephew is autistic, and is it safe, and can he be vaccinated?
Yes. We actually, I'm a neurologist, and we have actually seen lots of cases of seizures, especially with the Omicron variant, right? A lot of kids come in with fits all of a sudden, since it's quite prolonged. So we actually are very aggressive in telling all our neurology patients and patient autism to please get the vaccination as soon as possible, because these kids get seizures, it can be an issue. Right? So now, especially with Omicron variant going around in circulation, I would strongly recommend the child gets vaccinated. Autism is not a contraindication for vaccination.
Okay, Dato, and another question for COVID-19 vaccination: how is this vaccine safety be monitored among children?
All in Malaysia, we have a system where any sort of adverse event is reported to the National Pharmaceutical Regulation. You know the data which I showed from all the cases which were given a vaccine, and then they actually, if you look at the MySejahtera as well, you can actually upload any side effects that your dependent has experienced on the vaccine. So this is how it is fed back to the National Pharmaceutical Regulatory Authorities. And this happens throughout the world, right? Throughout the world, whenever they the vaccine, they actually ask the people to report back any side effects. So this is a reporting by the individual who has experienced the side effect or whose dependents have experienced the side effect.
Okay, thank you, Dato. And next question is there a fertility or development concerns with vaccinating children before they reach puberty?
I'm sorry?
Is there a fertility or development concerns with vaccinating children before they reach puberty?
Actually, most vaccines are given the first year of life. And we give vaccine the first year of life, for a few decades now, right? So this issue, and the only vaccine which you give around the time of puberty will be the vaccine which you give for hemopapillomavirus vaccine we give the girls at center 6. But most of the other vaccines are given in first year of life.
Okay, thanks, Dato. And let me just quickly get the other question. Is it safe to get the COVID-19 vaccine simultaneously as the other vaccines?
Okay. If you take one or two vaccinations, you must have the same day, right? If you take a vaccine today, you take a vaccine next week, your body won't respond to the vaccine next week, right? So if you look, for example, at our system of vaccination, for example, you notice that some of the vaccination are combined. We are combining 6 antigens in one injection. So the kids don't get 6 injections, they only get 1 injection at 3, 5, and 18 months. So this is, for example, we give hepatitis and and we give polio vaccine, diphtheria, tetanus, pertussis, hip vaccine. We're giving it all together in one injection, and then the body responds, right? So similarly, if you were to give the COVID vaccine with another vaccine on the same day, the body also responds. You give it today, and then you take another vaccine 1 week's time, the body will not respond. You have to wait about a month before you take the next vaccine.
Okay, thanks, Dato. We will take one last question. What can we do to convince parents who are against vaccinating their children or even themselves to change their minds, Dato?
Well, the idea of this presentation was to try to convince those not convinced about the safety and the necessity for this. We need to control the pandemic, right? And the only way we've managed to control the pandemic in some countries is by vaccination. Here in Malaysia, because large population is actually immunized, notice the Omicron variant has caused rather mild disease, right? Because the population is vaccinated. So, globally speaking, the vaccination has succeeded in controlling serious manifestations of the new variants in those populations that are vaccinated. Whereas in those populations not vaccinated, they are still having serious complications of the new variants. So, the data is very solid. Yeah? So I'm not too sure why people still are hesitant. We've got very good safety data, we've got very good efficacy data. So, it's difficult people to sort of refuse now. Because maybe 1 year ago we're not sure, but now we've got very good data. And to still be hesitant, I think, is not very logical.
Okay, thank you, Dato. And with that, we have reached the end of today's event. Dato Hussain, can we get a final word from you to the audience?
Right. I would like to stress that vaccination is been a very useful tool in pediatrics. Because of vaccination, we have very successfully reduced infant mortality in many countries, including Malaysia. And we continue to use vaccines to prevent diseases. The COVID-19 outbreak can only be effectively controlled if there are enough individuals vaccinated across all ages, right? So I really would appeal to all of those not vaccinated to please go ahead and get vaccinated, and also to follow and to subscribe to the pediatric vaccinations which our country is offering. Malaysia is one of the few countries in the world which offers so many antigens free of charge to everybody, right? Many other countries, even in our neighboring countries, beyond the basic 6, you need to pay for it. Right? Malaysia, everything is free of us. We should be grateful, and we should take the opportunity to protect our children, our loved ones from infection. Thank you very much.
Okay, thank you so much, Dato, for that final word. And if to the audience, if you have any other questions, please feel free to email us at inquiry@rcsi.ucd.edu.my. Once you leave the session, you'll receive a short survey on today's keynote session, and we would appreciate it if you could answer that and provide us your feedback. You will also receive a follow-up email with a link to view this recording within 48 hours. And finally, on behalf of RCSI and UCD Malaysia campus and our panelists for today, Dato Hussain, we would like to thank you for joining us today. We'll see you soon in our next keynote session. Until then, take care and stay safe, everyone. Thank you so much, Dato.
My pleasure. Good night.
Bye-bye. Yeah.